In this lesson, we are only discussing reference angles. Reference angles refer to any non-quadrantal angle. And what it is, once you have an angle that's non-quadrantal, also it's not going to be in quadrant 1, it's given some measure theta. The reference angle is the measurement from the terminal side of that angle to the x-axis in the nearest direction. So for this first one, theta is in quadrant 2. The reference angle is this distance. In the second example, theta is in quadrant 3. So the reference angle is from 180 degrees to the terminal side. And then in the final one, the angle theta is in quadrant 4. The reference angle is from that terminal side back to the x-axis. Please, please be aware that you are never measuring from the terminal side to the y-axis. It is always to the x-axis. So here's an example. If theta is 120 degrees, the reference angle is from this terminal side down to 180. So I would take 180 degrees minus 120, and my reference angle would be 60 degrees. In the second one, we could call theta 218 degrees. Well, the reference angle here starts at 180 and continues beyond it. So I would say 218 minus 180 gives us a reference angle of 38 degrees. And then in this last example, we could say this angle is 307 degrees. So here I need to go from 307 all the way around to the 360 degree mark. And that one is 53 degrees. Please note that these reference angles are always positive. So here's our first example. Find the reference angle for each angle. So I'll start with the one that's 294 degrees, and the first thing that I'm going to do is sketch the angle. 294 degrees, I know, is somewhere in quadrant 4. So that's going to help me figure out which part of the x-axis I need to measure to. And I can see I have to calculate from 360. So I can take 360 degrees minus 294 degrees. This reference angle is 66 degrees. The next one is a little bit trickier, and the first thing that I have to do is find the angle that is the least positive angle coterminal with this. Do you remember how to do that? You start with your 883 degrees and you subtract out 360 until you get a value that is in between 0 and 360. So that's 523. Subtract out 360 again, and we get 163 degrees. So now that I have this coterminal angle, I can sketch it, and I know that 163 degrees is somewhere in quadrant 2. So my reference angle is here. That means I'll take 180 degrees minus 163 degrees, and I get a reference angle of 17 degrees. For the next example, we're asked to find the values of the 6 trig functions for 135 degrees. It does not say the exact values, but in this case you are not being asked to plug these into your calculator. The first thing that you need to do is find the reference angle for 135 degrees. So again, I might sketch it. I see that 135 degrees is in quadrant 2, which gives me a reference angle of 45 degrees. In the last lesson, we did a lot with 45-degree angles. If you remember, we used this right triangle. That was a 45, 45, 90 triangle. So with this information, we can actually get all the 6 trig functions without needing a calculator. The only thing that we have to pay attention to is the fact that this is in quadrant 2. So remember, we talked about all students take calculus. Because it's a quadrant 2 angle, sine and cosecant will be positive. Everything else will be negative. So I can begin, and I don't want to write sine of 45. What I want is sine of 135. And I'll put in here that that's going to be negative. This one will be negative. And this one will be negative. So when I start this, looking at this reference triangle, I can say the sine of 45 degrees is opposite over hypotenuse, so that's 1 divided by the square root of 2. I need to rationalize this denominator, and this becomes the square root of 2 over 2. If I take the reciprocal of that, I will actually take the reciprocal of my original because there's less work to do. And this gives me the square root of 2 over 1, which is simply the square root of 2. When I look at the cosine again, if I take cosine of this 45-degree angle, adjacent over hypotenuse is 1 over the square root of 2. It's exactly the same as the one above it, so this will be the square root of 2 over 2 as well. However, because this is located in quadrant 2, the cosine will be negative. For tangent, we do sine over cosine, so that would be the square root of 2 over 2 divided by the negative square root of 2 over 2. Otherwise, we could do opposite over adjacent. There's your 45, opposite over adjacent. Either way, we can see that we've got the same things in the numerator and denominator, but we know that, again, because of the location, this must be negative, so the tangent is negative 1. The secant is going to be the reciprocal of cosine, which will end up being the square root of 2, but it's got to be negative because only sine and cosecant can be positive. And the cotangent will also be negative 1 because it's the reciprocal of the tangent. Our final example is asking for exact values of each expression. So we'll start with the first one, sine of negative 150. Once again, I will always sketch this. Negative 150 degrees, remember, it's going to travel clockwise. If it traveled all the way back, it would be negative 180. So I know that negative 150 has to be somewhere in quadrant 3. I can find the least positive coterminal angle with this, which would be positive 210. Although that isn't really necessary. I can also find, and should find, the reference angle. That's really what we're looking for, is this reference angle. The reference angle will be positive, and in this case it is 30 degrees. So now I'm looking for the sine of a 30-degree angle. However, remember, all students take calculus. In quadrant 3, tangent is the only thing that's positive. So sine is going to have to be negative. I can do this without my calculator if I remember that special right triangle, the 30, 60, 90. The ratio was 1 to square root of 3. Sine is opposite over hypotenuse. So the sine of negative 150 degrees will be negative 1/2. For the next angle, 780, the first thing that I need to do is to find the least positive coterminal angle. So I'll take 780 minus 360, which gives me 420, and I'll take 420 minus 360, and that gives me 60 degrees. If I look at this on the coordinate plane, this is a positive angle that'll wrap around several times. There's 360, there's 720, and it wraps around again and ends up here at 60 degrees. Because this is a quadrant 1 angle, all of the trig functions are going to be positive. I can reference this triangle once again. I'm looking at the 60. We know that tangent is opposite over adjacent, so cotangent would be adjacent over opposite. So the cotangent of 780 degrees will be 1 over the square root of 3, which I then have to rationalize, and I get square root of 3 over 3.